Hello, my name is Gerald Mills. I'm a geographer. I'm a physical geographer. I'm based in University College of Dublin, and the focus of my research has been the climates of cities. And that's been the case for the last 35 years. So much of my research is associated with understanding the climates of cities and how we can actually improve the climates of cities through good planning and good design. Well, more than half the population of the Earth now live in cities. And the climates in cities are completely different from the background climates in which the city is located. That means that in terms of all the basic physical processes, the atmospheric exchanges, the quality of the air, the water systems, the quality of the water, these are all dramatically changed. As a consequence, the climates that most people experience in a city isn't the climate that's often recorded at a meteorological station. The temperature is different, the humidity is different, the wind is different, the rainfall is different. In other words, urban climates are an attempt to understand what is about the nature of the city itself that has modified the background climate to create the climates that most people experience inside the city. Yeah, this is probably the best known of all the urban effects. It's the urban effect on temperature. Now, people often misunderstand the urban heat island. First of all, why is it an island? It's an island simply because the temperature inside the city is higher than the temperature in the natural surrounding environment. So we describe the urban heat island largely as a difference in temperature. That's air temperature, that's surface temperature, and that's subsurface temperature in the urbanized landscape when compared against the background. So in other words, when we measure the urban heat island, what we're trying to do is identify what the urban temperature effect is. So we can figure out what part of the climate in the city is due to the urbanization effect and separate out from the part of the climate that's not got to do with urbanization. So for most of our understanding of the urban heat island has been based upon the air temperature. So it's an island because as I move from the outskirts of the city into the interior of the city, the air temperature gets warmer and warmer by comparison with the outside city air temperature. And that's what's known as the urban heat island. It has been measured for over 200 years, but the air temperature urban heat island is strongest at nighttime. Strongest at nighttime under clear skies with very little wind, and that's because it's largely the effect of cooling. Cities cool more slowly than the natural environments outside the city. Since the 1970s, we've been able to get much better understanding of the surface urban heat island. That's the skin temperature of the surface, the tops of roofs of buildings, the walls, the ground, etc. And this information has largely come from satellites. So the satellite-derived surface urban heat island shows that the urban surface is also warmer than the area around it, largely because it's completely paved. This is the key thing. The main reason why you have an urban heat island is because of the removal of natural vegetation and its replacement by paving. That's the main reason. The second reason for it is the fact that all these materials that are impermeable, hard, they're all arranged to make buildings, and the buildings themselves create all sorts of reflection patterns and block out the sky, and that's the second reason why you get an urban heat island. The third reason is the type of materials that we use inside cities, which are designed to always be dry. So unlike the natural environment, the city rarely changes. Apart from the vegetation that's left in the city, most of the city returns very quickly back to what it was previously, a hard, paved surface. And the final thing is all the traffic, all the buildings, all the people, every one of these things all emit energy into the atmosphere, and they also contribute to the heat island. So we have the surface urban heat island and the air temperature urban heat island. Both of them represent a very, very strong indication of the intensity of urbanization. And that's why you'll always find the strongest urban heat islands are to be found in the most paved surfaces close to the city centre. Essentially, as I already indicated, half the population of the planet now live in cities. But in fact, if you look at the extent to which cities occupy the planetary landscape, probably about 1% of the land area of the planet is actually urbanized. In other words, converted into urban uses. And yet about 70% of the global carbon dioxide emissions come out of that very, very small area. So in other words, cities are primary drivers of global climate change. Now, if I flip it over and say, okay, where are most cities located? They're located at low altitudes, they're often located along rivers, and they're often located very close to coasts. In other words, they tend to be located in risky environments, subject to lots of hazards. So the reason why people are so concerned about cities and global climate change is, one, if we can regulate emissions from the cities, we can try to moderate global climate change. And two, we're going to have to protect cities into the future from the consequences of climate change. So what are those consequences? Well, one of them is sea level rise. That's an almost certainty. Well, sea level rise for many cities which are located on coasts means that they are going to experience coastal flooding. Another consequence of global climate change will almost certainly be warming. So not only will the climate get warmer, but it'll be warmer on top of an urban heat island. In other words, the heat stress experienced inside cities, which are already warmer than the areas around them, will be greater under global climate change. And that's why if you're going to try and modify the planet and try to address global climate change issues, a very good place to start is with cities. Now, why does the urban heat island matter? Well, if the urban heat island is a measure of the urban effect, then I can change the city and I can measure how I've changed the city based upon the magnitude of the urban heat island. And presumably, I could also therefore get an indicator as to whether cities are adjusting so that they are not having an impact on global climate change and so that they are resilient to the impacts of global climate change. How did I start this conversation? I said that I was a physical geographer. So you might ask, why is the study of urban climates a topic for a physical geographer? Well, a very strong tradition in geography has always been to understand the relationship between humans and their environment. And generally speaking, this has been taken to big scale global environments. But in fact, the city environment, the urban environment, is entirely created by humans. So I'm fascinated by the fact that we live in climates that we effectively have created, both indoor and clearly in outdoors. In other words, it's entirely within our control to modify the city, the place we've built, and therefore modify the climates that people experience. And that's why it's a topic for a physical geographer such as myself. So thanks for this conversation.